All right, guys, we are picking up with section 7.6, part 2, and we are talking about exponential equations. Remember, an exponential equation is when the variable occurs in the exponent. Otherwise, you just got an equation with exponential expressions here. And we said the step to solve these is to make sure that both of our bases are the same. So we wrote both of these, we rewrote both of them as base 2. So this became 2 to the 2x, 2 to the 5th. And once our bases are the same, we've got a property that says, hey, if your bases are the same, then your exponents must also be the same. 2x equals 5. And when we solve for x, we were right in the middle of finishing this one when the video cut off. We get x equals 5 over 2. All right, let's try another one. 25 to the x equals 1 over 125. First, I need to make their bases the same. And because I know my powers here, I've got 25 and 125. I know that I can rewrite both of those with a base 5. So I'm going to rewrite 25 to the x power as 5 squared to the x power, and 1 over 125 as 1 over 5 cubed. Now, once I've done that, I almost have them so that the bases are the same, except for my one on the left is a base 5, and the one on the right is a 1 over 5. But I can rewrite that 1 over 5 to the third with a negative exponent. So if I rewrite it as 5 to the negative third power, that's the same thing. Remember that negative exponent just means inverse. So the inverse of 5 to the third, or 1 over 5 to the third. So I now have 5 to the 2x equals 5 to the negative third power. Once my bases are the same, I know then that I can say that my exponents are also the same. So 2x equals negative 3. At that point, we divide by 2 to solve for x, and we get x equals negative 3 over 2. All right, for 5a, we're going to take a look at how to solve a literal equation here. And this is an equation that is used when we're talking about the swinging of a pendulum here. And we want to solve this for L here, and that is going to represent the length of the pendulum. You might see this equation again when we're doing some problems in class. And to solve this for L, first we want to isolate our radical expression, right? So we're going to divide by 2 pi. So we get t divided by 2 pi equals the square root of L over g. We can then go ahead and square both sides possibly, right, to get rid of that root there. So we've got L over g, and we've got t squared equals 4 pi squared. Now, you might have rewritten that as the square root of L over the square root of g, thinking about how we were splitting those fractions and rationalizing the denominator there. But it's a whole lot easier just to square this guy right from the beginning and get rid of it all the way around. All right, we then need to get L by itself. Right now, L is being divided by g. The way that we undo that division by g is to multiply by g. So we're going to multiply both sides by g, which leaves us with L equals t squared g divided by 4 pi squared. So remember that when solving for literal equations, what you're trying to do is get the letter that's being asked for by itself on one side and everything else on the other side. So using that, we're going to think of g. G, by the way, stands for gravity, and we've got this rate of gravity is 32 feet per second squared, and that's not just a made-up number. Anytime that you are doing any kind of physics problems involving motion or gravity, you're going to see that g is 32 feet per second squared. If you're dealing with the customary measurement system here of feet, if you're dealing with meters, you're going to be looking at 9.8 meters per second squared. But for right now, we're dealing with feet, 32 feet. So using this, we want to find the length of a pendulum with a period of 3 seconds here. And a period is, we'll talk about periodic functions, but a period is like how long does it take to go back and forth. So if you start your pendulum on the left side, let's say here, and it goes here, and then it swings back, that's 1 period. So to go back to where it started, 1 period. So it's got a period of 3 seconds. We want to find the length of the pendulum. L standing for length of the pendulum. T is for time, so let's plug in what we know. Our time is t squared, so 3 seconds squared. Our g is 32 feet per second squared. And we're dividing all of that by 4 pi squared. So what we have is 9 seconds squared times 32 feet divided by second squared equals 4 pi squared. Now notice we've kept our units of measure here. And if this is over 1 and we were multiplying that, hopefully you see what's going to happen with those second squareds. They are going to cancel because one's on top of our fraction, if you will, and the other one is down here on the bottom of that fraction. Our 4 and our 32 can also simplify and become 8. So we've got 9 times 8 feet, or 72, divided by pi squared feet. If we were wanting to put that in decimal form, we would type that into our calculator and get 72 divided by pi squared, which is going to give us approximately 7.30 feet. Remember that pi is actually more precise because it doesn't contain any decimals and it's not having to be rounded off after a certain point. But when we do calculate with pi, well, we can't write all the decimals because it's never ending. So we do have to round at some point, which makes it a little less precise than the actual pi itself. All right, guys, that concludes part 2 of 7.6. So we have looked at radical and exponential equations and the difference between a radical equation, an equation containing radicals, and an exponential equation and an equation containing exponents. Remember that for radical equations and exponential equations both, the variables in the fill in the blank. For radicals, it's in the radical, and for exponential equations, it's in the exponent. And both of those do have similar steps when solving. First, we want to isolate that radical, and then we want to raise it to the appropriate power. And once we have it raised to the appropriate power and we've eliminated the radical, then we follow the steps of algebra. For exponential equations, remember that we want to write both sides as powers of the same base. So if we have 2 to the x power equals 8, we're going to rewrite that as 2 to the x power equals 2 to the third. And then we've got that property of exponents that says if our bases are the same, then our exponents must also be equal. And so we could say that x equals 3. Hopefully you guys have all those steps. You've got all those definitions. If you have any other questions, make sure that you write those down. And I will see you guys in class with all of your questions.